So I do think it's possible that at the moment there is one civilization in the Milky Way. Holy wow, this is amazing! We are going to be learning so much in the coming decades. Located 7 trillion miles away from Earth is an unprecedented discovery made by the James Webb Telescope, City Lights in Space. This remarkable finding has ignited a strong wave of curiosity about the possibility of extraterrestrial life. Join us on this cosmic journey. Joe Rogan, the James Webb Telescope just observed city light 7 trillion miles away. The telescope focused on Proxima Centauri b, the closest exoplanet to Earth, showing unusual bright lights emanating from it. What could be responsible for these city lights on Proxima Centauri b? Could this signify the presence of life? Come with us as we delve into how the James Webb Telescope detected these extraordinary objects in space. For years now, scientists and humans, in general, have researched to get a glimpse of life beyond our solar system. Any evidence perceived to back up this fantasy about space has been gladly welcomed over time. Recently, the scientific community got the shock of their lives when solid evidence of life forms existing in space was observed by the James Webb Space Telescope. While scouting outer space and relaying vital information back to Earth, the James Webb Space Telescope noticed strange city lights shining from the exoplanet Proxima Centauri b. Just as its name implied, the city lights looked like they lit up a distant city. The possibility of an alien city existing on the star has left scientists reeling in amazement. Every one of them is baffled because it seems like this is the existence they've all been waiting for. If this turns out to be true, as everyone thinks it is, it means that there are intelligent life forms organizing civilizations foreign to what humans know in outer space, and we are only just discovering it. Peering into the city lights located 7 trillion miles from Earth, NASA engineers can't help but wonder how long these lights have shone in space, waiting for humans to grow the required technology to detect them. David Kipping, an astronomer from Columbia University, describes the Proxima exoplanet where the city lights were found as tricky. He said so because this star system nearest to us has varied heating patterns that aren't similar to other planets. The usual rocky planets are known to take in sunlight and emit infrared radiation. However, it's not so for this exoplanet, as its infrared nature is quite different from that of its host star, named Proxima Centauri. This makes for a good observation by the James Webb Space Telescope, JWST, and the telescope came in handy as the right tool for the job. The JWST is able to easily detect infrared wavelengths. The characteristic heat signature of Proxima b will play a huge role in discovering the universal secrets of its atmosphere. This will be a result of the latest technological advancements in infrared imaging capabilities possessed by the JWST. Scientists plan on utilizing the telescope to reveal the mystery surrounding this planet's atmospheric conditions. They also aim to use the Webb telescope to check the possibilities of residing on this exoplanet. The James Webb Telescope has an infrared sensitivity that's required to explore what happens at Proxima Centauri b's nighttime, picking up the faintest rays of light in the cosmic darkness, usually a struggle for space telescopes, but not for the JWST. It can pick out even the tiniest rays of light from space. It's the perfect instrument to verify if the rumors of city lights on Proxima b's night side are true or false. Every artificial illumination in the cosmos can be sensed by the telescope as long as it falls within a frequency band that's 1,000 times narrower than starlight. How does Proxima Centauri b compare to planet Earth? Proxima b has an interesting relationship between its stellar features and surface interactions. The day side of the exoplanet contains many solar panels that harness the bubbling radiant energy possessed by the star. Its spectral edge also reflects incoming light rays at the same time. When Proxima b completes its orbit around its host star, Proxima Centauri, it experiences day and night periods just like we have on Earth, with the daytime getting high on solar heat and the evening experiencing coolness. The planet is known to have temperature fluctuations that are determined by its composition. For example, if there's no atmosphere on Proxima b, the difference between its day and night periods will be wide and far between. If there's no moderating influence of atmospheric gases and oceans, the temperature of the day side will be so hot like a black body, and the night side will horribly drop into cold darkness. The degree of temperature variation is a good subject for astronomers to unravel a deeper understanding of Proxima's atmospheric composition. Having an unrivaled infrared imaging capability, the JWST can efficiently examine the planet's thermal emissions to provide insightful data about its atmospheric properties. Interestingly, the orbit of the James Webb Telescope around the Earth falls in alignment with Proxima B's orbital period, making complete observations of its day and night periods within 11.2 Earth days. If it indeed has an atmosphere, the next step will be to assess its atmospheric chemistry to determine if it can accommodate life. Some good pointers in determining if there's life are the presence of gases like oxygen, water vapor, and methane. If these elements can be found on the planet, it means that it supports habitable conditions. The process of successfully determining this requires scientists to be meticulous enough as they capture and examine light rays that move through the planet's atmosphere. This is an incredibly challenging task to undertake, even if the JWST possesses great capabilities for characterizing planetary atmospheres. It has a different major objective. The telescope has been designed to only analyze the variations in water vapor, carbon dioxide, and methane concentration. When it comes to identifying bonded oxygen, which is a vital indicator of life, the JWST is limited in this area. Even so, the telescope still has valid reasons to search for other elements on the planet. One of such reasons is ozone, which gives away an accurate level of vitality in the atmosphere. It's also worth noting that the James Webb Space Telescope doesn't have absolute capabilities, and it can only peer at a few of the closest habitable worlds to Earth, carrying out a thorough atmospheric investigation. Astronomers are now tilting toward ground-based observatories like the Extremely Large Telescope, ELT, fondly referred to as ELT. The ELT is a telescope that has been scheduled to start operating in 2028, and it's carefully positioned to gaze deeper into the atmospheric structure of faraway exoplanets. It'll produce data on these planets that will offer comprehensive and vivid insight into their level of habitability. NASA scientists and everyone are happily waiting for the deployment of future space telescopes like these. Until then, however, the James Webb Space Telescope will continue to be a vital tool in our quest to uncover the mysteries of distant exoplanets. Even with its current limitations, the James Webb Telescope has the potential to offer deep insights that will revolutionize our understanding of exoplanetary exploration now and in the future. Scientists have an objective for future space telescopes, and that is to reduce the amount of bright light coming from a planet's host star so that astronomers can clearly see the lights reflected from a planet itself. They plan to do this by using internal masks or gigantic external satellites that are shaped like an umbrella, similar to using your hand to block out rays of the sun to enable you to see an object clearer. In the bid to reduce the fierce brightness coming from the host star, future telescopes will be better positioned to study faint reflections of light coming from a distant planet, allowing for clear analysis of its atmosphere and the likelihood of supporting life. Doing this comes with its own challenges, however. Scientists will have to differentiate between gases generated from life and those generated from geological processes, such as volcanic activity. Astronomers aren't relenting in their bid to understand the characteristics of exoplanets, so they're more able to discover signs of life and distinguish them from false positives. The Webb telescope contains a preview of scientific advancements from the research of exoplanets, offering a sneak peek into the amazing discoveries we're yet to find. As we stretch our understanding and exploration of the cosmos farther and farther, we are better positioned to understand the intricate workings of the universe and our various roles in it. After looking through all the planets in space, scientists have yet to find any that host life despite decades of searching. Searching through space for signs of life, the quest for forms of life on other planets continues. Are we alone in the universe? For millions of years throughout human civilizations, humans have always wondered whether they are the only ones living in the universe. This is a very old longing that still hasn't left us in this present time. Even today, scientists have the James Webb Telescope in outer space, trying to spot alien civilizations hidden amongst us while studying all kinds of planetary bodies for signs of life. At the same time, the narrative that some aliens are truly out there in the stars, just waiting for humans to find them, is indeed a popular narrative. To provide an answer to this question, two American astronomers, Jill Tarter and Thomas Pearson, started a project called the Search for Extraterrestrial Intelligence, SETI, in 1984, known as the SETI Institute. This is a non-profit venture that plans to sift through cosmic signals to pick up only radio signals from space. Radio signals have the ability to travel through long distances without getting scattered or absorbed like other types of radiation, hence their decision to focus on them. Due to this characteristic feature, radio signals are more likely to be detected by the 42 radio telescopes that constitute the Stellar Allen Telescope Array, found in the Cascade Mountains of California. Though the SETI Institute has religiously observed signs of these radio signals generated by alien life, there haven't been any such signals for over 30 years. Jill Tarter is enthusiastic that they'll have a positive result as they want to use the tools of the 21st century to accelerate the search. In the words of Jill, "I wish that you would empower Earthlings everywhere to become active participants in the ultimate search for cosmic company." Taking a broader look at the grand scheme of things, one can't help but wonder what could be preventing us from getting the required positive feedback despite all the tools at our disposal. Even after investigating different phenomena, we still have the same result: we haven't found alien life yet. There are several probable answers to why it's been so difficult to discover other life forms. One answer might be that there are indeed several alien civilizations present in the Milky Way galaxy. Still, they possess extreme technical knowledge and are way more advanced than humans, in that their civilizations are simply undetectable. They're so advanced and different from our regular world that we cannot comprehend how to relate to them. Another answer may be that they do not want to interfere with our natural evolutionary process. As a result, they are careful not to bring their presence to our attention. Either way, these alien civilizations may be hiding in plain sight, existing at the very edge of our perceptions. Humans also could have tried searching in places where no intelligent life exists. The James Webb Telescope could help us find one soon. Astronomers are enthusiastic about the arrival of space telescopes like the JWST and others that will help in reducing the brightness of the host star to reveal the hidden wonders of a planet. A planet's ability to host life is no longer a far-fetched idea, as we'll be able to analyze and evaluate the chemical compositions and atmospheric conditions of various planets, starting with the city lights found on Proxima Centauri b. It's only a matter of time before we unveil the mysteries surrounding other life forms hidden in plain sight. Thanks for joining us on this cosmic journey. Tell us your opinions in the comments section below. Don't forget to like, subscribe, and click the video on your screen for more mind-bending content. Until next time, keep gazing at the stars. This is Cosmic Inquiries, signing off.